All right. Good morning, good evening, everyone. Welcome back again. This is going to be second demo session for our database course. Uh, Quickly recap what we covered yesterday. It was a brilliant discussion, a lot of questions, queries, and able to complete couple of demo topics, whatever was planned. We'll continue with that along with that yesterday's session after the recap, and then we'll take up all the questions and queries. So again, as I said, you can feel free to unmute yourself, ask any questions or queries, or use this chat window to post your questions or queries. I'll be monitoring this chat window and I'll take up all your questions and queries. Right. So we yesterday that was the demo session one, and followed by today it's a second demo session. In our yesterday's demo session, we started with the introduction about myself and my overall experience and my whatever the database activities and overall expertise in Oracle world, right? So whatever my contribution, everything we briefly discussed, followed by the course curriculum for this particular course. What is the course curriculum, course content, what is included and what is not included, everything we discussed, followed by the course duration, course fees, course timing, all we have discussed. And with that, we started with some of the basic administration activities for my database as part of this demo classes. We started with understanding database connectivity, how as a DBA, I will connect to my database, how as an application user or the end user, they will connect to my database using TNS and listener concept. So we understood that one. And we connected our database using SQL developer. Again, that's one of the tool, right? So there are various tools or various client softwares the end users can connect to my database with the help of the TNS and the listener. And we understand about the types of database, various types of databases like standalone, Oracle Restart, Oracle Rack, Oracle Rack OneNode. And then we understand the differences between standalone versus Rack. And we understand the installation process, how it varies from standalone to Oracle Restart server to Oracle Rack server, various installation process and some of the basic administration like once a user login, how we can log into that Oracle user and connect to the database. Right, couple of things we discussed as part of our yesterday's demo session. So we're going to start with the second demo session today. Today is going to be last demo session for this particular database course. And as part of this second demo session, we'll see some more admin activities. Right. With that, I can quickly bring up our yesterday's slide here. So as I said, 13th April and 14th April, yesterday and today, Thursday, yesterday and then today, Friday, or two demo sessions. Again, timings, what you guys are connected right now, 9 a.m. IST to 11 a.m. IST, pretty much 11:30 p.m. EST to 1:30 a.m. EST. 2 hours yesterday and 2 hours today are dedicated for these demo sessions, the Zoom link and meeting ID and passcode. And actual course for this particular course is going to start from 17th April, that is starting from coming Monday. So as I can get my calendar here, 13th yesterday and 14th today are two demo classes, followed by weekend, 15th and 16th. 17th is the one we're going to start the actual database course starting from this Monday. So again, timing remains same, 9 a.m. IST to 11 a.m. IST, or pretty much 11:30 p.m. EST to 1:30 a.m. EST. And this is going to be weekday batch, Monday to Friday, and same timing, 9 a.m. to 11 a.m. IST, 11:30 p.m. EST to 1:30 a.m. EST, every day 2 hours, Monday to Friday. And pretty much course duration is of 45 days, varies from 40 to 45 days. And the course fees, of course, it's a paid training. The course fees is 10,000 Indian rupees, that pretty much 125 US dollar. And the mode of this training is online via Zoom session or WebEx or Teams. We're going to discuss. And this is going to be Oracle 19C version, right? So with that, I got a couple of students registered yesterday, and I have added everyone to WhatsApp group. As I said, we have a dedicated WhatsApp group for each batch, and any questions, any queries will be discussed in that particular group. Any information will be shared in that particular group. And That WhatsApp group will be available for lifetime support even after the course completion. So you can ask or post your any questions or queries. We'll be able to help you on that. Yeah, that's a WhatsApp group. We are having it for each batch has its own dedicated WhatsApp group. And who are interested for further continuation of this course, feel free to reach out to me on my cell number or WhatsApp number +919880616848 and or drop me an email mallikarjun.ramdurg@gmail.com. I can connect with you one-to-one for further administration, like further registration and the further payment process and all those things. Right. Having said that, couple of interesting factors. This is a one-time registration fees, and once you pay, you can attend multiple times with the valid reasons. The valid reasons comes like you register for this particular batch and you're not able to continue with this particular batch because of some reason, like you went into some abroad for higher education, or you got some on-site opportunities and you have to travel, or you have some personal emergency, or your shift timing got changed. So whatever the reason, you have to intimate well in advance so that I can prepare, I can take your name in the next batch. So if you come at the last minute and tell that, I did not attended my previous batch, I want to attend this particular batch which is going to start. So I cannot accommodate at the last minute. So it has to be well in advance so that I can plan it. So because there's a limited student for each batch. So at the end moment, everyone comes and then, ask for without any reason. So I cannot take it at the end moment. So it has to be planned in well advance and intimated in well in advance so that I can make it adjustment. Right. So that's a important note as part of this course. I can quickly go over here. Again, we discussed about course curriculum. So this is my course curriculum. Go to my blog, malik034blogspot.com. So go over this important keynotes and the other details, and followed by the course curriculum. We explained or detailed discussed in yesterday's session about what are the topics included. So there are like 24 to 25 topics, and followed by 3 extra topics will be part of this course. You can go through all this course curriculum. And again, here is a course registration link. You can open the course registration link. So you can put your name, email ID, phone number, and submit your registration. And also, if you want to know more details, you can click on this more information. So that will going to give you upcoming batch, what is the new batch is going to be scheduled and all those things. Right. So I'm just gonna put all these details in the chart here. So whomever missed yesterday, so just make a note of this. I pinged here in the chart window. You can just take a note of that. Right. So with that, again, I'll reiterate. So one of the prerequisites for this particular course, you should have minimum 8 GB RAM and 100 GB SSD hard disk in your laptop. So we're gonna use Oracle VirtualBox, and we're gonna set up a lab on your own laptop. So you should have minimum 8 GB RAM in your laptop or desktop, and you should have minimum 100 GB SSD hard disk so that you can do a setup and you can work a lab exercise. If you don't have these prerequisites, so probably you'll not be able to do a setup lab and you'll not be able to do a hands-on, right? Um, that is very important. So if you don't have it, so probably you will be able to listen the course and understand the course, but you'll not be able to do hands-on lab exercise. Right. Again, there is a time concerns for US guys and IST Indian guys here because when I say the course timing, let's go here. When I take course timing is 9 a.m. IST to 11 a.m. IST. So pretty much when it is Friday, today is a Friday, 9 a.m. IST, pretty much in US, it will be 13th. It will be of 11:30 p.m. It will be like 12 hours or 12 and a half hours will be like lagging, right? So when I say it is Friday here, so pretty much for anyways, it will be like 1 day lagging. So you have to accordingly plan it. So when I say the course is going to start on 17th April, Monday, 9 a.m. IST in India, so that pretty much 1 day behind in US, like it will be 16 April and 11:30 p.m. EST. So that you need to make sure that the timing you have to adjust. Right. So with that, any questions or queries? I'm gonna give 2 minutes. I'm gonna pause for 1 or 2 more minutes to take up any questions or queries. Anyone has it for this course? Want to discuss anything regarding the course? Or you can feel free to unmute and ask or post your question here in the chat before I get into the technical discussion for the demo session too.
Hi Malik, this is Nagesh.
Yeah, Nagesh. Yeah, go ahead.
Yeah, regarding Linux commands which we are using in our Oracle day-to-day activities, is there
Mhm.
any separate session or we will learn according to the class commands which we are?
Whatever needed for the database administration as a DBA, whatever commands needed will be covered here as part of this course. So anybody has any questions or queries and you want to learn extra Linux commands or basics or administration, you can post it in our group. So I'll take 1 or 2 extra sessions to just to cover the basic command.
Yeah.
Yeah.
Regarding Saturday and Sunday, yesterday you told for anyone who is new to Oracle course or Oracle.
Again, I told yesterday there are already pre-recorded basic sessions. Probably I'll be granting access to everyone
Yeah.
who are new to this database world or database course or entering into this DBA. So you can go through those all the plain recording, no questions, queries there. It's just this one-to-one discussion like I just recorded. So that will help you to understand more basics. You can go through all of them. There are like 40, 50 videos, like just 2 to 5 minute videos, and you will be able to understand. On top of that, if you want to understand more about the basics, I'll be happy to cover on Saturday and Sunday 1 or 2 extra sessions for who are like new to this Oracle world. So just to cover the basic flavor, like how it works.
Okay, thank you.
All right. Yeah. So
Greetings.
go ahead.
I'm sorry, I have a question. So I have a Microsoft Surface Pro. Will I be able to use that, or it has to be an actual laptop?
I need to check that how Microsoft Pro works. Probably pretty much once again. Pretty much this Oracle Virtual Box should work. I need to take a look on that. I'll take any of your questions. Microsoft Surface Pro, whether it is supported with the lab or not, I'll let you know. Or probably you can ping me on my WhatsApp number. I can connect with you. I'll do some research on this Microsoft Surface Pro is supported with our virtual box. Pretty much we're going to use this. Let me get it. We're going to use for our lab exercise. We're going to use this Oracle virtual box. So I just wanted to make a compatibility whether this is supported with the Microsoft Surface Pro. If it is supported, then probably we can use it. You can say Windows host. Windows host probably includes everything, whatever Windows it's supported. Well, yeah, I can confirm you on that. You can ping me on my WhatsApp number.
Okay, thank you.
All right. Any questions, guys? Before we get into that technical discussion, I'm planning to cover a couple of more some of the basics for this particular demonstration, like DB maintenance, database files, and database backend processes and memory structure and all those things. Before we get into the technical understanding discussion, any questions about the course curriculum, course timing, course duration, or the fee structure, uh, or whatever, feel free to ask me any questions here. This is the opportunities. Yep.
Malik, it's Yusuf.
Yeah, please go ahead.
I asked yesterday a question about OED, Oracle United Directory. Have you, it's used to replace the tailsname.org.
No,
Are there something in this course about this? Thanks.
no, I lost you in the middle. Come again. What is that requirement?
OED is Oracle United Directory. It's
Okay.
used to replace the tailsname.org. Have you something
No,
about this in this course?
no, no, no. That's not covered.
Okay, thanks.
All right. All right. So if no further questions or queries, let's continue with our technical discussion for this today demo session, and we'll see how it gonna goes. Right. Let's get it over here. Right. So I can quickly go ahead and then we'll talk about that. Give me a second, some background noise. All right. Let's go here. Again, I logged into this Oracle Lab 1. So let's take it one more time. So what we discussed yesterday. So you will be in your data center. It may be wherever it is. It may be in London or wherever it is. So in your data center, so you'll be having your own servers. Let's say, assume that I'm going to take only one server, Oracle Lab 1. Oracle Lab 1. Right, sorry for that background noise. Okay, so let's take, this is your London data center. That's what we're discussing. So in order to access your database server, so this is my database server. So it will be having a host name and IP address 192.168.1.1.1, whatever the IP address. So as a DBA, we are going to connect to this server, and inside that you will be running your databases. Like say you have DevDB, or you have a TestDB, or you have ProdDB. You will be installing your databases on the server. So Oracle Lab 1, you're going to connect this server using a host name or IP address. So if you assume here, I have connected to my Oracle Lab 1. So if I do ps-ef grep, ps is a process list, Linux command to list out all your Oracle database installed over here. So DB2 is the database that is installed. DB2 is the name of the database. That's the name of the database instance. So running with Oracle user here. Right. So you might be having any database. You might be created multiple databases, or you might be created only one database. Right now, I have created multiple databases. DB2 is a one. DB2 is a one. So that database instance is created over here. And I have one more database installed on this server. I'll just gonna start that one. So that is my DB1. So that is just a name of the database or name of the instance, you can call it for now. I'm going to do startup. So that is shut down now. So when I do ps-ef grep s1, that gave me only one instance name. So it means only one database running on this particular server as of now. So now I set it to DB1. I connected to my SQL plus SSDB, the SQL command prompt for the DB1. I did a startup. That was down, and I did a startup. Now database is started. So if I run the same ps command here now, so if I run this ps-ef grep s1, now I can see two databases, DB1 and DB2. In this server right now, two databases were installed, or two databases were created. Let's connect one more database. I have one more database, that is DB3, and connect back SQL plus as is DBA. So again, that is down now. As of now, it is down. So again, do startup. Right. So mounted and database is opened. So exit. Again, now if you do same ps command, ps-ef grep s1, they're gonna give you three databases. So this command is basically give you how many database instance currently up and running on your server. This is my Oracle Lab 1. Let's increase the font here. So this is my Oracle Lab 1 is a server. In that right now, DB1, DB2, DB3, three database instance we're running. So we understand yesterday the database understanding with correlation to our human life. Where is that slide? Let me get that slide. Right, so we understand this particular concept in comparison with our human life. So there's a database instance running on the server first, and that database instance will be having a memory plus background process. So if you can see here, so I have a DB1, DB2, and DB3. These three database instances has its own background process here. So there will be a bunch of background processes. So ps-ef grep. If I want to list out all the background process for my DB1 database, I'll just do ps-ef grep DB1. So I'm going to get for this DB1 database instance, these are the background processes. So some of the mandatory background processes are your log writer, LGWR, DB W0, DB writer, and your checkpointer, and your PMON, SMON. So these are like your mandatory background process. Some are like non-mandatory background process. So these are your mandatory or non-mandatory background processes, what we saw here. So it will be having a background process, bunch of background process to read and write into my database. And memory structure, each and every database has its own memory structure, SGA and PGA. SGA stands for System Global Area or Shared Global Area. PGA stands for Program Global Area or Private Global Area. So inside those SGA and PGA, there are so many other sub-memory components. Like inside SGA, there are shared pool, large pool, Java pool, stream pool, DB buffer cache, redo buffer cache. There are so many sub-memory component, right? So that memory component you can easily identify the moment you connect to your db3.orinv, set the environment to the db3 and connect to your database, the db3 database connected to idle instance, connected to your SQL command prompt. The moment you do startup, you're going to get all the memory component, your SGA, PGA, all the memory will be allocated. All inside SGA, all the shared pool, large pool, Java pool, stream pool, DB buffer cache, redo buffer cache, all the memory will be allocated. And at the same time, all the background process will be started. That is the simple understanding of your instance. A instance is nothing but combination of your database memory and database background process. Combining together, we can call it as an instance that will be running on a Linux server, right? So there might be multiple instances running on a server. So right now here on this, if I do one background process, ps-ef grep, your pmon is one background process. If I search for that background process, pmon, ps-ef grep pmon, that pmon will give me pmon of db1, pmon of db3, pmon of db2. So it means 3 pmon process for 3 database instances. Right now on this server, 3 database instances are configured. So instance means memory plus background process, right? That is your instance. And what is database? This is your database. Database is the actual data files, each and every database instance and database is tied together. One instance and one database, one-to-one mapping. So database 2, DB2 has its own data files. That is your actual database of the physical files. And DB3 instance has its own database. That's the data files or the physical files. And DB1 has its own data files or the physical files at my OS level. So if I can go here, U01, app, Oracle, Data. So if I do LSF and LTR, so I have DB1, DB2, DB3, 3 separate directory. And if I go into my DB1 and if I go into data file, LL, so these are my data file systems, syssock, temp, undo users. These are the data files for my DB1 database. So whatever the DB1 database has its own set of database. If I can go to DB2 data files. So again, DB2 has its own set of data files. If I do PWD, present working directory, that's a DB2. Now, if I go to DB3 and data files, and these are the data files for my DB3. So each and every database has its one-to-one mapping, one instance mapped to one database. So I cannot map multiple databases to one single instance, like it's one-to-one mapping. One instance associated with one database. Database means your actual data files residing under the storage. So that database is mapped with your particular instance. That is one-to-one mapping. Right. So let's quickly, now we understood about what is database. Database is actual data files residing under your storage. It may be local storage or NFS, SAN or ASM storage, wherever you can keep your data files or the database. And in order to access those data files or the database, right now you can see these are the data files. Whatever the end user, whatever the business transactions are going to happen, all those transactions are going to store it under the data files. So in order to read or write those data files, those database, the instance will act as a mediator. So any end user, like for example, client one, want to access the data. So here the table T1 here, to write a data into the table T1. So this client want to write a data into T1, or the client want to read the data from the table. To read and write data from that particular data file or from that particular database, there is no direct read and write into data files. There should be some mediator. That mediator is your instance. So this client cannot connect to that data files, cannot connect to the database. He has to connect to your instance first. Once he connect to instance, with the help of this memory structure, with the help of this background process, he can read that data or he can write the data, or he can read the data with the help of that instance. Like how this human will interact with other persons, I need to read or write, the instance is mandatory. Any end users or the clients are all connecting to my instance. Via instance, they can communicate with my database to read or write any data from the database, the data file. The instance is mandatory. Right. So that is simple understanding. Now we got to know instance is a memory plus background process. That's what we saw here. So we have a lot of bunch of background process for each instance. And the moment you start your instance, will be bunch of background memory structure will be allocated for that instance. And data files, each and every instance associated to a particular data files or the database at the backend storage. That's what we saw here. So these are the data files associated to the DB1, DB2, and DB3. Right. So there are so many, this is just a data file I'm talking about. But in order to form this entire structure together, we can call it as a Oracle database server. Instance plus your database or the data file combining together, we can call it as a Oracle database server. Oracle database server is nothing but your Linux server where your database is running. So your Oracle database server is a combination of your instance plus your database, the data files. So your database or the data files are nothing but backend storage where your data files are going to reside. That is your database or the storage files. And your instance is memory plus background process. Combining together your instance and database or the data files, it will be your database server, Oracle database server. Oracle database server is nothing but your Linux server where you install your instance and database together. That's your Oracle database server. Right. And in order to your Oracle database server to work, right now, what I can say here, if I can take here, PS-EF, grep smon, I have this DB1. So let's put them here. So I have the DB1, I have DB2, I have DB3. I have 3 database instances. So this is my database instance. Again, instance means memory plus BG process. So DB1 instance and DB2 instance and DB3 instance, memory plus background process. Each of these 3 instances has its own memory and its own background process. And each of these DBs have its own database. So this is instance and DB1 database. So if I put here DB2 database and DB3 database. So these are database means actual data files belongs to that particular DB1 database. So where are these DB1 data files? So if I go here, this is my DB1 data files. So similarly, my DB2 has its own database, so the data files, and my DB3 has its own data files here. Right. What is database instance? Database instance is a memory plus background process. What is database server? Oracle database server or database server, you can call it as whatever. Oracle database server. What is Oracle database server? Oracle database server. So I can say DB1 Oracle database server and DB2 Oracle database server and DB3 Oracle database server. The typical naming convention. Oracle database server is nothing but your instance plus your database. Typically, instance and database names are remain same. Like DB3 is your database instance and DB3 is your database. So names are remain same. Database name and instance name. Your instance and database combining together, that will call your Oracle database server. So same thing goes for your database 2. Database 2 instance and database 2 data files combining makes my DB2 Oracle database server. DB1 Oracle database server, again, the DB1 instance and DB1 data files combining together, they're going to form my Oracle database server, right? So this is just a naming convention. So, nothing hard and fast rule to you have to remember. And then because now we're not going to use it for day-to-day activities. So once you know the basic concept, how the naming terminology works, so that will make you, for whenever anybody asks any questions, you'll be able to explain or understand. But we're not going to use it for day-to-day activities, these naming terminologies, right? For admin activities. But you should understand instance means memory plus background process. Database means my actual backend data files where the end user data is going to store. Combining together instance plus database, it's going to make my Oracle database server. So that Oracle database server, DB1 database server, is nothing but your Linux server. So Linux server here in this case, Oracle Lab 1. So again, in this case also, Oracle Lab 1. Again, in this case also, Oracle Lab 1. So people will call it Oracle DB1, that particular database and Oracle database server, particular database name and database server. So 3 database, Oracle database server running under one Linux server. There may be a scenario, one server, only one Oracle database server. In this scenario here, one single Linux server, you're running 3 Oracle database servers. Right, so that's a simple correlation how we can do this, use this naming terminologies. Right, let's go now. So now we understand instance, now we understand database, now we understand Oracle database server, and now we understood about the backend storage or the data files. So in order to work this entire database server, right, your instance and your database server, this is one single setup, and this is your second setup. I'm going to use this database for my HR application. So for my HR application, I'm going to use this database DB1. For my finance application, I'm going to use this particular database. And for my marketing application, I'm going to use this particular database. So each application you can point individual databases, or you can multiple application, you can point to a single database. You can do whatever customization you want it. So in that case, in order to work this entire database, there are so many files are needed at the backend. So these are your so many files what are needed for your database to operate. So you need a control file in order to run your database. You need a parameter file and SP file in order to start your database. And you need the data files. These are your actual end user business data. So whatever you saw here, the data files, system, sysocks, temp, undo users, these are your actual data files. And you need this temp and undo data files. So you can see here your temp files, and you can see your undo data files. So you need your temp and undo data files along with your system, sysocks, your system, sysocks, and user data files. Along with that, you need this temp and undo in order to run your database. And you need your redo log files to do online transactions. You need your arclog files, the copy of your online redo log files, arclog files. If you take a backup of your control files, data files, your undo, temp, online log files, or your arclog files as a backup copy, if you take it, that's your backup files. And you need a password file in order to connect to your database. You have a sys user to connect to database remotely for admin activities. You need a password file. And in order to monitor your database instance, whatever your database instance running under this server here, DB1, DB2, DB3, all these database instance has its own bunch of trace files, alert log files, and some of the monitoring audit files, and so many other files will be getting generated. So these are your backend storage. We just say the data file is that's going to form your database instance, and your actual data files. So instance is memory plus background process, and data files are your actual data files, what you're seeing here. So combining your data file database and the instance will form your Oracle database server, but that is not enough to run or to function your database server. To function or to run your database server, there are a bunch of other backend files are needed. Those are listed over here. So you need a control file, you need a SP file, password file, you need a parameter file, you need a data file, temp, undo, you need a password file, alert log file, trace file, redo log files, arclog files. These all are the backend files which are very much needed for my database instance to function properly, my database server to work properly, right? So these are your backend files, what you can see, right? So we can quickly see for one of the database, all these files, how it looks like. So I can set DB1 or DB2. So let's go for DB2. Set the environment to DB2. So this is the command. In order to connect to any database, first you need to do ps-ef grep smon. Understand which instance you want to connect, which database you want to connect. I want to connect to DB2. So run this ps-ef grep smon command. You're going to get that instance up and running or not. The output shows that DB2 instance is up and running, and you should understand who is the owner of that. Okay, Oracle is the owner. You have to log into the respective owner. Right now, I already log into that owner. I no need to log in again. So I logged into Oracle user already, owner of that instance. And now I need to run this dot space vara env. That's the environmental variable provided by Oracle. The moment you run this dot vara env, it'll ask what SID, what instance ID you want to connect. So DB2 instance I want to connect, or DB1 I want to connect, or DB3 I want to connect. Give just that instance name. The moment you set that, it's going to set all the environmental variable. You can validate using env pipeline grep capital vara. That'll tell you, okay, SID is set here, Oracle base is set here, Oracle home is set here. Again, many people will get confused who are new to this Oracle. What is this base? What is this home? We'll discuss separately once we start our actual class. Right. So we set the environment for DB2 now by running this env grep vara. That's gonna confirm that, okay, and everything is set to DB2. I can simply connect to my database. So now the SQL command prompt is your actual admin command prompt to manage that particular database or database instance. So very first command, show parameter SP file. Show parameter SP file. So that's going to give you show parameter SP file. I'll just take a note here. First parameter file, SP file or P file. SP file or the P file. The moment you run this command, show parameter SP file, that's going to give you whether your database is started with a P file or SP file. So it says Oracle home under DBS location. I started my database with the SP file. So these are like, again, don't worry about SP file and P file. SP file is a binary file and P file is your parameter file, human readable text formatted. And your database, when you start it, it's going to either use SP file or P file. First, it's going to look for SP file. If not, then it's going to go for P file. Any one file is needed in order to start your database instance. So from the P file, you can create SP file, or from the SP file, you can create a P file. Right. Give me 1 second here. Right. Sorry for that. Okay. What I'm talking is the P file or SP file are mandatory to start your database. Once your database started, those are not needed anymore. When you did here startup, when you connected to your database, DB3 connected to idle instance, the moment you do startup, it'll go to your DBS location, and inside DBS location, it look for the respective SP file. If not, then look for a P file. If not, your instance will not start. Either of SP file and P file are mandatory. Right. Right now I have, let's create, again, as I said, from the P file, you can create a SP file. From SP file, you can create a P file. Both are, one is a binary file and one is a text file. Both are same. Create P file from SP file. Right, I can exit. I'll go to this location, DB home, DBS location. So if I do ls-ltr SP file, the naming convention is SP file followed by your SID, that is your db2.varam. Right, so this is your SP file, that's a binary file. And again, ls-ltr, list that P file now. So SP file starts with the SP file.varam from this location. Wait a second. So this is your SP file location, like DBS location, and followed by your SP file name. The P file, it'll not be the P file name, it's an init file. So it will be init and your db2.varam. So this is your P file name. Same path, and the name will be like this. Init, your sid.varam. So SP file will be with SP file name. The P file will be with init name. So that's a simple understanding how we can differentiate P file or SP file. Okay, that's your very first file will be read when you start your database instance. And after that, you're going to read the control file. So control file, again, you can go to your database, connect back to your database, select name from $, control file. So let's list it out here. I'll just say CF control file. CT or CF or whatever it is, control file. So SP file and P file, these two files ends with .vara. One is binary and one is your text human readable format. Both ends with the .vara. Control file, again, after the SP file is read, your database will read control file in order to go to mount mode. Again, we'll talk database modes from shutdown to no mount to mount, mount to open. We'll discuss during our actual course. But first file will be read SP file or P file, followed by you're going to read your control file and your database will go to mount mode. Control file is again, it's a binary file, which typically naming convention ends with .ctl. CTL stands for control file. So you have a two control file, one control file more than enough to run your database. So it is called multiplex control file. The duplicate copy of the same control file is available here. One is under VARA data and one is under your FRA, fast recovery area. That is called multiplex control file. It means one control file, if you lose, you can easily copy that second control file and then you can start your database. That's a multiplex control file. Right. And next is your data files. Once the control file is read, and now your database will get opened by reading a data file. Select name from $, data file. So these are your data files. So again, there will be so many data files: system, sysocs, undo, users, temp, so many data files. So these are the data files actual end user business data is going to store here. Any user, application user connects and create a table T1, insert some 1 million record, and user 2 connected and created table 2 and inserted 1 million record. Whatever they do insert data, all will fall under a particular that application related user data files. So there'll be hundreds of data files for each database. So actual end data is going to store it under these particular data files. So these data files are again binary files and extension ends with .dbf. Like that's an extension of that. So along with that, again, we'll talk in our actual classes, what is the use of this system data file? What's the use of your sysoc data files? What is the use of this undo data files? What's the use of this user data files? And what is the use of your temp data files? There are so many data files. So I can say my data files includes, let's put it over here, my system data file, my sysocs data file, and my user data files. And I have special data file called temp. I have again special data file called undo. Temp is for your temporary sorting operation, ascending and descending. Any user do select star from employee table, order by employee ID, order by employee name, ascending, descending, whatever that order by clause they use, we're going to make use of this temp data file for sorting and ordering. And undo is for if you do any update, like employee one having a salary 1,000 and one user connected and he will gonna make that employee salary as a 2,000. If you do any update, the previous image, previous data will be stored it under this undo data files. These are like special data files to help for the end user transaction. One is for sorting, temporary sorting operation, ascending or descending. One data file is undo. Undo is for your holding your previous copy, previous information. Whenever any end user do update statement, modification statement, the old data will go into your undo data files, right? Again, don't worry about this command, what we're going to use here. Sometimes I'm going to use the $, and sometimes I'm going to use the DB underscore dynamic views. So $, is called dynamic performance views. DB underscore whatever I use, it's called your data dictionary views. We're going to talk about a special class. There's one special topic. The dynamic views, that's a $, and the dictionary view, that's a DB underscore. We'll talk about that. For now, I wanted to cover what are these, right? Right now we covered SP file and P file, and control file we covered. And data file we covered. Data file includes your system, sysaux users, and special data files like undo and temp. All are your data files. And now your online read log files for any transactions. If user is doing the transactions, insert, update, delete. So all those transactions will be stored under this online read log files. Select member from VDLR log file. So these are your online log files. Online log files, or you can say transaction log files. So we have online log file 1 and the copy of that. Again, this naming convention is stand for O1MF is OMF, Oracle managed files. Oracle will give that naming convention. Again, there's a separate topic for this OMF. We're going to talk about that. Like we have a copy 1 and the duplicate copy of the same log files. Again, it's a multiplex of your read log. How control file multiplexing here. Control file 1 is copied here. The same thing, online read log 1 is copied here as a copy of that same file. So in order to lose whenever you lose one read log files, you can make use of other read log files to recover that. One is under VARA data and one is under fast recovery area. And you have read log 2 and copy of that. Read log 3 and copy of that. 3 online read log files. Actually, 1, 2, 3 are the online read log files and duplicate copy of them are here. So you have 3 online read log files with the multiplexed. For the transactions, any transactions are going to happen, the transaction details will be stored under this online read log files here. Right? Go back here now. So that's your online read log files. So these online read log files are very small in file, like small in size, like, only 100 MB or 200 MB or 100 GB. So whenever there's a transactions or commit or a lot of, whenever that read log is full, and Oracle will start overwriting them. Like for example, I have this read log 1 now and read log 2 and then read log 3. And right now, whenever any users are doing, like 100 users are connected to my database, they're all doing the transactions. All you're writing into read log 1, the transaction information. Once this read log 1 is full, automatically Oracle will start writing into read log 2. Once the read log 2 full, and Oracle will start writing into read log 3. And once the read log is also 3 full, and Oracle will again start writing into your read log 1 again. So whatever the existing content will be deleted and it's overwritten. So again, the transactions will be lost, right? If it overwrites. So for that, in order to not to lose the transaction information, we copy this read log as a archive log 1, archive log. And once this read log again full, Oracle will start writing into read log 2. And the read log writer, before writing into this one, your archive process is gonna back up those as a archive log files. So archive log files are nothing but your redo log files. It will be backed up before it rewrites. Before the log writer rewrites, your archiver process, this archiver background process will take a backup of that. That's your archive log files. Archive log files are nothing but your online redo log file copies. Right. So just to, in order to preserve those transactions for 1 hour, 1 hour or 6 hours or 12 hours or 1 day, 2 day, last 7 days, I want to preserve all the transaction information. So you're gonna enable this archive log. That's a background process. You have to enable that, put your database in archive log mode. That's gonna keep preserving those online read log content as a backup. That's your archive log files. So for that, you can do archive log list. You can do this command, archive log files. What is archive log files? It's a copy of your online log files. Archive background process is going to take a backup of your online log files. So do archive log list. It's going to tell you whether it is archive log mode enabled or not. Archive log mode is enabled means your archiver process is enabled. Archiver process is going to take a backup of your online log file as archive log files. And it's enabled, and this is the location for that archive logs. So DB recovery file. So then I'll do show parameter, and whatever it shows, DB recovery file list. Sorry, show parameter recovery. Just do show parameter recovery along with that. So this archive log list will tell you whether archive is enabled or not. Once the archive is enabled, where those archive logs are going. So right now, this is the archive location. That if I can go here in this location and show you Oracle log files and DB2 and DB2 and then archive logs, LSF-LTR. So this is a location for your archive logs. So your fast recovery area, FRA, DB2, instance name and database name and archive log. And in that archive log, each date specific archive logs, the transaction log will be backed up over here. Right, so that's your archive logs. Go back here now. And by any reason, if you take your SP file, P file, or control files, data files, or undo temp, or online log files, or archive log files, if you take a backup of these files, these are the files very like necessary for my database to operate. And if these files, if you take a backup, that are your backup files. How you're going to take a backup? You can take a using hot backup. Again, we'll discuss doing the RMAN backups and restore recoveries. What is hot backup? You can take a manual backup, or you can take a user managed backup. There are many methods to take a backup: hot backup or manual backup. Hot backup, or you can say one more cold backup, that is shutdown. It's a downtime backup. Cold backup, you can take all these files. You can take a cold backup copy or hot backup copy, or manual backup you can take, or user managed backup you can take, or these are like old traditional old method of backing up your these files. And nowadays, most of the enterprise or many customers are going to use RMAN. RMAN is a recovery manager. RMAN stands for recovery manager, again provided by Oracle. This is the tool provided by Oracle. And we're going to use this RMAN tool for any backup, restore, recoveries. Your SP file, control file, data files, your archive files, online log files, any data file, any of these files, backups, restore, recoveries. We're going to use this RMAN tool to do a backup and restore and recoveries. And in fact, RMAN cloning, duplicate, everything, we're going to use RMAN tool. So once you take a backup, that's your backup copies. You can take any of these manual method. That's a traditional old method, or you can use RMAN automated. It's a fully automated tool. You can use this tool for backing up, right? So that's your backend files. And now two more files, password files and the alert log files. Alert log files and the trace files. Again, these are your monitoring your database health. So your alert log and your trace files for monitoring your database instance, to monitoring your database and monitoring your database health checks, all those things will be logged over here in this alert log files and the trace files. So alert log files, you can find it out using locate command. Locate, the name will be alert underscore your instance name db2.log. So this is the command. You can use this locate command. That's going to give you the alert log file of my db2 instance. If I do the same locate command for my db1, locate db1, I can get my alert db1.log file for my database 1 instance. If I go for db3, that will be for my database 3 alert log files. So you can use this locate command. That's one thing to locate your alert log file. Right, so you can use this locate command if locate command works in your environment. If not, can connect to your database and you can say select start from $, diag underscore. Again, don't worry about what is this diag and all those things we'll cover during our actual sessions. There'll be a lot of things here. 12 rows are selected. What I'm interested here, go all the way top. We select start from $, diag underscore info. So what I'm looking here, my trace file, the diag trace is the one. So this is a location where your alert log and the other trace files will be located. That's a trace. So you have to run this command. And inside your SQL command prompt, and you have to look for this, the diag trace. So if you go into that diag trace, if you go in the directory, you're going to get that respective alert log. Let's exit and go into that location. CD, change directory. I'm going to that location. Do LSF and LTR. And that's going to give you all the trace files and all the alert log files. Like you can see your all the background processes has its own respective log files here. Like, I can get it. Okay, your log writer, your archiver, and if I can go further down, or you can do lsfltr pmon, or you can do star pmon, and all the pmon particular process for whenever it crashes or whenever issue occurs with that pmon process, you're going to generate the particular trace file and the trm file. Trm file is a binary file we cannot read, and the trace file is a human readable text format. So what is happening with that particular trace file, what is happening with that particular process, you're going to dump over here. And at the same time, if you check for your alert, you'll be having your alert log file here, right? So let's take one duplicate session. Let's quickly take one duplicate session. Give me a second. Right, so let's go back here now. I taken one duplicate session for that same Oracle lab one. So now what I'll do, I'll go here and I'll go here and I'm going to tail this -f alert log. So whatever happens with your database instance or database, so that'll be logged in this particular alert log. So I'll just split my window into dual mode. Right, so this is your tail -f. You did alert log tail here. Now I'll connect to my database here. So I'll do shut immediate. So the moment I do shut immediate, you can see in your alert log here, the shutdown started here. Closing your window and cleaning up, shutting down your Oracle instance started here. So you're going to shut down your all the processes and you're going to shut down your all the database backend processes, release the memory, and commit all the transactions. All these things going to happen here. Your database is dismounted and your instance shutdown completed. So now I'll just connect back again. Connected to idle instance. The moment you do startup, and let's see here. The moment you do startup, starting Oracle instance, and if you scroll down here, and you can see this is your Oracle home. From the Oracle home, you can see reading server side SP file. This is the SP file. What we talked, you're going to read this SP file and you're going to open your database. Okay, in that SP file, again, these are like your SP file parameter key values. We will talk in detail in our regular class, right? So whatever happens inside your database, everything will be like, alerted or logged into this Oracle alert log or the respective trace file, right? Single window. Right, so those are your all the files. We talked about all of them, and we have one special file here that's called password file. So again, that password file will be on the same location. So the password file, again, it's not a mandatory one, and we'll understand why we need a password file. Let's go to your Oracle home. Again, under same DBS location, and you have this Vara PW and DB2 PWD, and let's put over here. 1 second, guys. Right, sorry for that. Okay, password file, again, same location. And the password file naming convention goes like this. Each database has the naming convention like this. Vara PW, that's a Vara password file, followed by your instance name, DB2, DB3, DB1, whatever the instance name. So again, this is a binary file. Why we need this password file? Again, it's not a mandatory one. This password file is needed for a sys user, sys admin user to connect to your database remotely to do any maintenance activity or administration activities like shutdown, startup, or any kind of maintenance activity you wanted to do remotely without logging to that server. For the remote authentication, for the remote connections for your sys admin or sys DBA user to do admin activities, your password file is very mandatory. That's a simple understanding. And also password file is needed for your archive log whatever the archive log is going to ship from primary to standby. In order to apply those archive log on the standby side, you should have a same password file from the primary to your standby side. In order to apply those transaction logs, the archive logs on the standby side, you need a same password file of your production. So that's other use case of your password file. Right, we'll discuss more on our actual classes, but these are the two use cases. Somebody asked what is the use of password file. One is for remote authentication for your sysdba user for any maintenance activity via remote connection. And the other one is your production and DR sync. Your password file is mandatory. Right. With that, those are your backend files. Those are your backend files, what we understood. And little bit, if you go on the front end side now, or not on the front end side, so little bit we go on the backend file, right? So here, what we understand this part so far. We understand database, that's your data files, typical data files, your system, sysocs, undo, user, temp, all those data files, along with other storage files, your password file, the SP file, P file, and your control files, your redo log files, archive log files, and so many other files. So whatever we understand this part right now, right? And now let's understand this instance part. Now we understand that backend storage part, whatever the backend storage side, whatever the possible available files, we understood everything. Now let's come to instance. Instance, we said memory plus background process. What are the memory? What are the background processes? Right, so simple thing, we already saw that one. PS-EF, grep, DB2, they are going to give you all the background process here. PMON, and again, these are like, some of them are mandatory, some of them are not mandatory. Diag, and your DB writer, log writer, checkpointer, SMON, and your archiver, right? So your archiver, slave process, so many archiver process. So they have so many background process. Some of them are mandatory and some of them are not mandatory. And coming to memory, it has a SGA and PGA. That again, we already saw here. Whenever you start your database instance, like startup, the memory will be allocated for your database instance. SQL plus /s is DBA. Show parameter memory. I'll just show memory. So parameter memory. There's so many other memory components, but what I'm interested is my SGA and PGA. Show parameter SGA. This is my SGA. SGA target approximately around 3 GB set here. Show parameter PGA. So we have approximately PGA aggregate limit set to 2 GB and aggregate target set to 1 GB. So that is your PGA. So you have a memory component. So coming to this memory and background process, bunch of background process, some of them are mandatory, some of them are not mandatory. So in the memory, we have a PGA and SGA. Again, PGA stands for private global area or program global area. SGA stands for system global area or shared global area. So in the memory, main component are PGA plus SGA. PGA is private global area or program global area. SGA is a system global area or shared global area. Again, PGA, there are so many sub-memory components, and in SGA also so many sub-memory components, like your shared pool. In SGA, I can few of them. 6 are like very important. They were gonna ask. That is your shared pool, large pool, Java pool, stream pool, DB buffer cache, log buffer cache. And in the background process, there are mandatory and non-mandatory. Some of the mandatory background process are your SMON, PMON, DB writer, log writer, checkpointer. And some of the non-mandatory are your archiver and recoverer, all those things. Right. And in simple slide, if I go further here, where is that one? Okay, here. So you have a PGA, and PGA again stack space and user global area. So that's a PGA component. And in the SGA shared global area, you have shared pool, large pool. Again, we'll discuss in further what is the use of, what is the buffer cache use. All the modified blocks will be kept under, or all the dirty buffers will be kept under in this particular buffer cache. So some of the common entry questions in the buffer cache, like, what is dirty buffer, what is pinned buffer, what is cache miss, what is cache hit, and all those things comes under this buffer cache. And all the online redo transactions will be kept under this buffer. And your shared pool for all your part SQL representation, SQL IDs, your execution plans will be in your shared pool. Large pool for your RMAN backup, restore, recovery, and export, import. Java pool, your Java virtual with JVM virtual Java applications, your application side, like Java pool will be used. Stream pool for your streaming, your table level streaming will be used for the stream pool. Again, for the database buffer cache, we have a key buffer, recycle buffer, NK buffer. That is for various buffer. And coming to background process here, one simple things. So in the background process, you have DB writer, check pointer, log writer, SMON, PMON, recoverer, and some other background processes for your. Some of them are mandatory and some of them are not mandatory. So that's your overall architecture. If somebody asked you to explain about database architecture, this is where your single slide you should be able to explain that. Let's go here. So this is your single Oracle database server architecture. If somebody, once you understand, once you learn about database course, and once you are working as a DBA, so one of the common interview questions, can you brief or can you explain about database architecture? And if you're able to explain this entire one single slide, that proves that your fundamentals of database concept is strong. Right. So I'll go in one flow how the database architecture works. If somebody asked you, can you brief about database architecture? Can you brief about how your database architecture works? So your answer should be, my database or my Oracle database server architecture mainly consists of three important parts: a memory and background process and the backend storage data files. Memory, background process, and backend storage files. These three components are part of my database architecture. Again, once again, memory, background process, and the backend storage or the backend data files. All three together consist of my database architecture. And memory and the background process together, we call it as an instance, right? You can see it over here. Your instance, that's nothing but memory plus background process. Combining together will form my database instance. My database instance and the backend database or backend data file together, it will form my database server. So that's your simple 2-3 words. Okay. And then inside memory, we have a PGA and we have a SGA, two major component inside memory. PGA stands for private global area or program global area. SGA stands for shared global area or system global area. And inside SGA, we have so many other memory components like shared pool, large pool, Java pool, stream pool, DB buffer cache, and redo buffer cache. And coming to background process, there are so many background processes are running for my instance, and some of them are mandatory and some of them are non-mandatory. So mandatory background processes are your check pointer, SMON, PMON, DB writer, log writer, and some of the non-mandatory background processes are your archiver, recover, and so many other background processes which are not mandatory. Right, so that's your instance details, memory plus background process. And coming to my backend storage, backend data files or backend storage files, there are so many storage files. Some of them are your SP file, P file, password file, control file, data files, undo, temp, trace file, alert log files, your online log files or archive log files. There are so many backend storage files. And out of that, like some of the mandatory files are your data files, control files, and your online data log files. These three are very, very mandatory. My SP file, password file are not mandatory for my database to run. Those, my SP file or the P file needed for only my database instance to start. Once it started, it no need. Password file, again, as I said, it's only for remote connection, it no need it. And my archive log files don't need it. That's a copy of my redo log files. But mandatory files are your control files and data files and the redo log files. Those are your mandatory files, right? So that is how you need to explain. Start with the memory, background process, and the backend storage files. Once you explain about that in one single words, in one single flow, if you want to, if somebody asked you how my database connections works and transactions works, if they ask in that manner, you should explain like this. A user is trying to connect to my database. He is going to pass the details. What are he's going to pass the details? Username and the password. Along with that, he's going to pass the TNS names. We understand yesterday TNS name, right? The TNS name consists of the host name, protocol, port, and the IP address or the database service name. All those he will put into the TNS name, TNS files, and he will pass that username and the TNS file. He's going to pass the details. The moment he passes the details, we have something called a listener process or listener service will be running under my database server. And that listener will take that incoming connections and the listener will validate whether whatever the username, password, and whatever that TNS name he provided, it's all valid, or whether it's authenticated user or not. Once the listener authenticates, okay, very first connection, the user connection taken by listener, that listener will start one server process for that user one. So client one connected, the server process one will be started for him. And listener will take that incoming connection and it will validate whether user is authorized or not. And then listener will come back, okay, you are authorized user, your all the information is authenticated, you can go ahead and connect to my database. So your user can directly connect to my database instance. And then once the user connected to my database instance, whatever the query he run it may be insert query, or it may be update query, or it may be delete query, or it may be select query. Whatever the query user runs, that transactions will be taken by that server process. One user connected, one server process will be started. And on behalf of that user, the server process, whatever started, that is going to execute that query inside my database instance. If it's a select query, that particular server process, whatever started, is going to go to data file, fetch the data, and then give it back to that user. That's a select query. If it's instance query, that user, whatever do insert, the server process will going to insert it on the memory here, insert, and later your DB writer take that whatever the new inserted record and write it to particular data file. Right, select or insert based upon whatever the transaction they will do. The server process will act on behalf of that user. And the user client 2 comes, and again, same thing happens. Listener will take that connections, validate the authentication, and if that is authorized user, and one more server process 2 will be started for him, and he will connect to my instance. And whatever the query he will do, insert, update, delete, and based upon the transactions, the server process will act accordingly, whether it's insert or update or delete. You want to do that one. Right. Any transactions, any users connected to my instance and do it, all the transactions are going to happen in my database buffer cache. So at the same times, whatever the transaction, whether it's insert or update, delete, the respective log will be written into your log files here, redo log buffer. So the transaction information will be written over here, the redo log buffer cache. Over a period of time, there's a log writer will take all the redo buffer cache information and generate the log files. Redo log file 1, redo log file 2 will be keep on writing those redo log files. And your DB writer, whatever the new data the clients are inserting into my buffer cache, over a period of time, your DB writer will take all those dirty buffer. We call it as the dirty buffer. Whatever the new or modified or inserted data here from the buffer cache, your DB writer will take all the data and it's going to write into my respective data files. And whatever the transaction information written on the redo buffer cache, your log writer, the background process will take the transaction information right into my online log files. And once the online log file 1 is full, my log writer will start writing into online log file 2. At that same time, your archive or background process will take that archive log, redo log 1 content as an archive log backup here. Once the log writer fill redo log 2, and it will start writing into redo log 1. Again, my archive log process take that redo log 2 backup copy. That's your archive log. It will generate archive log 1, 2, 3. It will keep on generating the archive log. That's archive process will take care of that. Right. So these are two important buffer caches, DB buffer cache to store or retrieve the data for that end user transactions. Buffer cache is main. To that do any transactions, the logs will be returned to my redo buffer cache. So from these two main buffer cache, DB buffer and log buffer, the respective DB writer and log writer will take those content and write into respective data files and the respective online redo log files. And archiver is a process which is going to take a backup of your redo log, online redo log files into archive location. And along with that, we have a SMON and PMON. SMON is for your system monitor. Sorry, SMON is for your system monitor. PMON is your process monitor. And PMON, the name indicate process monitor. Process means one user connected, one process is started, server process. Second user connected, second server process is started. 100 user connected, 100 server process are started. Your PMON will be keep on monitoring those processes. And in case of user one is disconnected due to some network issue or connection timeout or idle timeout, whatever the resource you are using, your PMON will clean up all those resources, all those logs inside my database. You're going to clean up those, all the, the session timeout or the network timeout, all the idle connections. That cleanup will be done by my PMON process. So SMON, again, a special background process, stands for system monitor, which is used for the instance recovery. In case of your instance crash happens, your memory crash happens, or your background process crash happens. So, or your server, Linux server where your database is running crash happens. So your SMON whenever next time you start your database instance, your S1 will come into picture. That's going to do instance recovery or the crash recovery. Instance recovery in case of rack, in case of standalone, it's a crash recovery. What is that meaning? Your S1 will do a roll forward or roll back. Roll forward means whatever the committed transaction, your S1 will do a roll forward, and whatever the uncommitted transaction, S1 will do a rollback. That's the task of your S1 to handle that instance recovery or crash recovery. Check pointer is a background process. On a regular interval, your check pointer will be keep on updating your control file and data file header to make your database in consistent state. Like 1,000 users are connected, 1,000 transactions are happening, and there will be 1,000 SCN number will be getting generated inside my database. SCN meaning system change number. Any transaction, do a commit or do a insert or create a table. Any thousands or millions of user connected, do a transactions, all will be getting generated with a new SCN number, system change number, SCN number. And those SCN number, your checkpoint will take that latest SCN number and update the control file and data file header to make the database in consistent state. And doing that in a regular interval will going to help for my database recovery, and it's going to help for my database restore and recovery to faster. Right? That's a job of your check pointer. And recover, again, we'll explain during our actual classes. Recover is mainly for your handling the distributed transactions. If the transactions are happening across the multiple database or multiple database instance, recover come into picture. Right? So that's your overall architecture, how the transactions, works inside my database. Right? So you should be able to explain how I explained in this particular 10, 15 minutes. So that is going to give a very good impression when somebody asked you to explain about database architecture, or somebody asked you to explain about how my database connectivity works. So from that user, how the listener is going to go, how the authentication works, and then how that user will be started with the server process and attached to that PGA. And if you're able to explain this concept, and that's going to give a very good impression. That is the starting question for any interview. If you can give for any interview, that is your first question for most of the interview. As per my experience, I can see very first thing you go for interview, they'll ask for this question: explain about database architecture, or can you explain about how the end user connection works? So if you're able to explain this, that's well and good. So that's going to give first good impression very beginning of the interview. Right? If they don't ask this particular question, what they will ask: what is the use of my SMON? What PMON processor does? What my DB writer does, what my log writer does, what my archive process does, what's the use of my listener, what server process does, what is my PGA, what is my SGA, what are the component of my SGA, what are the component of my PGA, right? So you should be able to explain independent of those component or overall architecture. Everything will be in a single shot. You should be able to explain it. All right. Any questions, guys, so far on the whatever the topic we covered? We covered about instance, we covered about memory, we covered about background processes, we covered about a lot of backend files. This is the list here, right? So once you understand this core fundamental architecture, what I told just now in detail, and as a DBA, what we do, we deal with all this component, all these backend files, all this memory component, all this background process, day-to-day work, we all deal with this particular component. That's it. Once you are able to understand this all component core fundamental architecture and what is needed, why needed, when needed, you should be able to work as a DBA and handle any day-to-day activities without any issue. Right. I'll give 1 or 2 more minutes to pause here and take any questions or queries. Couple of questions here in the chat. I'll just take SP file or P file, which is readable, sir. Again, as I said already, SP file is a binary file, cannot read. P file is a text file, you can read it. And both are available inside DBS location, Oracle Home, DBS location. Where is that one? Okay, here, both are under SP file, both are under this DBS location, Oracle Home. First priority goes to SP file, that's a binary file. Oracle will try looking for SP file. If it is not available, it will look for a P file. And if both are available, it start with the SP file. And if SP file is not available, look for a P file. If P file is not available, it throw that error message. I am unable to identify either SP file or P file. Your instance will not start. Right? So your SP file is a binary, P file is a text file. That's a readable one. Right. And again, one more question here. What is the $V? Again, as I said, we have two things we're going to cover in our actual classes. Views, we call it as a views inside database. One is $V views and one is DB underscore views. So $V is called dynamic performance views, and one is the DB underscore. DB underscore, we can call it as a dictionary views. So these are the two things we use, either $V or we use either DB underscore. Just to give you example here, both are same queries. Whichever you are comfortable, you can use it. One is describe $V data files. Again, how you can remember, how you can identify all of them, all comes under based upon your practice. So I can say $V data file here. I can say name, select name from $V data file. Sorry, name from. Again, this is too early for who are new to this Oracle. They can't able to understand what is $V. In simple word, what I said, $V views, those are called the views, and one is $V and one is the DBA. $V is called dynamic performance views coming from the memory. DB underscore is the data dictionary views. We can call it as a data dictionary views that is coming from your disk. So I can run this command. It's going to give me a list of data files. So equivalent to that, that's a dynamic performance views. $V is the dynamic performance views. Equivalent to $V data file, I can run DB underscore. So I can do describe. Describe is to describe that structure of that view. Describe DB underscore data underscore files. So that is like your same thing. Like I can say select file name from DB underscore data underscore files. Let's copy it over here, put it here. So it is left to you, DBA, when to use, what to use, based upon experience and based upon practice, you can make use of that. So $V database give me same result, and DB underscore data file give me same result. Again, based upon how you practice, how you are comfortable with that. Sometimes we use $V, sometimes we use a DB underscore. And the simple understanding is one is coming from memory, one is coming from your disk. Those are called views, dynamic performance views and data dictionary views. It's left to you. You can use whatever you're comfortable. Right. So one more question: how many database we can create against instance? How many database? One instance, one database. There is no multiple options here. As I said here yesterday, if you might have attended, we have one instance, one database mapping. Again, second instance, second database mapping. It's always one-to-one mapping. And if you want to go for multiple instance, it should be a rack. So one single database residing under stage disk, that's your data files here, DBA data files. And you have Linux server one instance, Linux server two, one instance, Linux server two, one more instance. You can have multiple instances running under multiple Linux servers, and all those instances can map to one single database. So in a single server, you can have only one instance mapped to one database. You cannot have multiple instances on the same server. So if you want a multiple instance, you have to go with a rack. Multiple server, Linux 1, Linux 2, Linux 3, 3 server, and you can start your 3 instances, instance 1, instance 2, instance 3. All 3 instances you can map to one single database. Right, that's your simple understanding. How many instances against how many database. Okay, one more question here. How do we know instance and DBs are available on server? Again, as I said, how do we know available or not? You have to connect to the database, run the command ps-ef grep smon. They are going to give you whether your instance is running or not. Once your instance is running, and assuming that I'm going to kill this one directly, kill -9, kill -9. Again, this is a Linux command. Kill is a Linux command. I'm going to kill all these processes. Kill means directly shut down everything with abnormally. So nothing is running. If I, as a DBA, if I log into this Oracle Lab 1, and my first thing is to check how many databases are running, how many instances we're running, I'm going to run this command ps-grep. Okay, nothing is running. What that mean? It indicates two things here. Either nothing is installed here, no database were installed here, no database were configured here. That's the one options. Either the DBs are all down. Two possible options here, right? So how I can make sure that whether the DBs are down or whether it's a brand new server, no databases. There's a file called cat etc or a tab file. You have to read this particular file. Put it over here. Right, there's a file ps-f grep s1, nothing is running. So that indicates two obvious options. One is either this is a brand new server, nothing is installed over here, or they installed it, but everything is down. Somebody has killed our database, we're all down for some maintenance. For that, I need to check this etc or a tab. And at the end, you can see this one configuration here. You have a DB1, DB2, DB3. That indicates, okay, this particular server has 3 database configured, but that is down. So then how I do, what I'll do, I'll run this .env. And what database instance I want to start? I want to start my DB1, set that environment, set. So verify using env, capital Vora. So DB1, Oracle base, Oracle set, connect your SQL plus / as DBA, connect it to idle instance and startup. Right, that answers your query, right? So how to identify which database are installed on the server? Simple command, run this ps-f grep s1. If the instance are created and configured, database created and configured, you're going to get the list here. If nothing is getting out, nothing is listing out, next job is to check for this Vora tab. And if the Vora tab entries are available, that indicates, okay, this database is configured here, but it is down. So my job is to set the Vora env, set the respective instance and start it. So once you start it, now you can query the same ps-f grep command. They're going to give you the database is up and running now. Right. Okay, one more questions here. How to understand redo log files is full and it's right the redo log. You no need to worry about that redo log full or redo log files are writing. It's all internal. Oracle will take care of that writing redo logs and all. As a DBA, one of the performance tuning factor, how many redo logs I can create? What will be my redo log size? That is how our answer should be. How we're going to write, what will write, it's none of our business. We no need to worry. Database will take care of that. As a DBA, my job is to how many redo logs I can create? 1, 2, 3, 4, 5, 10, 20, 30. And what's the size of the redo logs? Is it 1 GB, 2 GB, 10 GB, 20 GB, or 100 GB? That is all based upon comes in the performance tuning. Based upon whether your database is a OLTP, whether your database is a OLAP, data warehouse, or online transaction processing, and how frequently commit are happening, how frequently the transactions are happening, how transactions are happening, how big is that. So based upon all those analysis, you're going to define how many redo logs I can create for my database, how big, what is the size of my redo log, I can define all of them. Right. Taking further more questions here.
Likarjan, Mukesh here.
Hey, Mukesh, yeah.
Yeah. So whatever the basic commands here you are firing on the Oracle, so that would be given to us during the course.
Right. Again, as I said, right, if I open my document, yesterday also I explained, I'm going to show you what I'm going to.
And you will be providing the recordings as well, right?
One second, I'm going to come to that point. So if you see here, right, so this is our yesterday's demo. I think probably who are registered for this course, they already got access on our Google Drive. And this is my yesterday's demo session. And in that demo session or on the regular classes, whatever command I'm running, I'll be taking that notepad. So this is the commands what I ran yesterday. I'll be uploading that command along with the video. When you're referring this video, and you can open this text file and you will be like practicing your own while listening the video, and you're gonna open the text file and you're gonna practice it. Whatever command we're running it here will be captured in a text file and will be uploaded along with the videos. You're gonna get it. Right.
Okay, got it.
Right. Yeah, meantime, anyone has any questions, you can feel free to unmute and ask. I'm gonna take further questions here in the chat. Okay, so some questions here. Are you going to discuss these topics again in the Monday's class? Yes, of course, these are the demo classes. I'm going with the speed and I'm wanted to cover as much as possible. When I start the regular classes on Monday, it'll be slow phase and will be covered in more detail about each and everything. So why we need, like, I just explained SP file and P file. What is there inside SP file? What is there inside P file? What is there inside control file? We have not discussed all of them. That needs a detailed analysis. That is part of your actual course. We're going to understand what is there inside password file and how many users are inside password file, what is there inside P file and password file, and inside SP file, how we can create a P file and SP file, how I can see what is the content of control file. That all part of our actual class. We're going to cover in detail about everything. Right. Going further, again, $view, DB, $view, again, we just covered. Environmental variable, again, we just covered. We're going to use just one single word, .var_env. Make sure that always use this .var_env. That solves all the environmental variable. Just run this .var_env. You're going to ask the SID, give that SID name. Everything will be set for you. You don't need to manually export or echo everything. Okay, how many database created in one instance? Again, one instance, one database. It's always one-to-one mapping. And if the server went down, DB automatically comes up? No, DB will never come automatically. You have to manually start everything. So if you want to start with a manual, you have to go with the, in fact, this is a good question. If you see my yesterday's type of database we discussed here, this is one of the automation. Your question is, if the DB server went down, will the DB automatically comes up when the server is back online? To answer that questions, in the standalone, we have two types. Standalone database without ASM, standalone database that is with the Oracle restart. The name indicates restart. If your database is running with ASM, that is called restart. So when your server goes down and later once the server is back online, your ASM instance automatically starts your database instance. You don't need to manually start it. And if you go with without ASM, when your server goes down and later once your server is back online, it will never start automatically. Manually, you have to start it. So in this particular Oracle Lab 1 here, it's all your no ASM. It's all your database instances, standalone. Here, if the server reboots, once the server is back online, manually you have to start all the database instance. And if you installed with ASM, again, we'll be covering as part of the actual course. We're going to install two server, Lab 1 and Lab 2, with ASM and without ASM. Both we're going to show the demo. So that's a Oracle restart feature. If the server reboots, automatically ASM will bring your database back online. You no need to worry about that. That's the answer.
Sorry, Mallikarjun.
Come again?
Yeah, sorry. Actually, whenever database goes down and it starts, so I think services automatically get started, right? So
No.
I'm not sure about the ASM.
Again, that's what I'm explaining. If database will come automatically online if you use ASM. If you don't use ASM, it will never start automatically. That's where I said with ASM, single instance called restart. Without ASM, it's called just a standalone. Standalone means if this Oracle Lab 1 server goes down, none of the database will come online. You have to manually start everything. However, if you have a ASM installed, then ASM will take care of that. It's going to bring all the database back online.
No, let's say I have installed the database Oracle LNG. I worked on that, okay? And I didn't install ASM and all.
It never come online. If your server goes up,
let's say if I restart, right? So all my listener services and my whatever services are there, that gets automatically started because it's on automatic mode.
Again, it never start. It never work on that. It never work. So you have to write some your shell script. You have to put into cron job, and whenever your server reboots, you have to put into your init.rc. You have to set all your configuration on that. That needs a manual effort. You have to write some automation script and then put them in order to start all of them. Otherwise, it never work. Automatic restart is not supported. It never work. Right. Couple of questions. Any limit of number of instances on the server? No limit, as long as you have enough memory, RAM, CPU on a server, you can create a number of instances. No limitation at all. Right. So for more question, what about the new DBA student? They are able to understand. Again, as I said, this course is meant for everyone. It's going to start from the scratch. It's going to go till advanced level. And I already 2 times repeated. I can take some extra sessions if you are new to this course and new to this DBA. I'm going to take some extra sessions, make sure that you understand everything. That's my job. I can take it as a weekend, Saturday, Sunday, some extra classes. Windows system, no, I'm not going to cover about Windows system. It's only on the Linux system. It will not be covered anything on a Windows or AX. It's only on Oracle Linux. All right. Right, that's the last question I can say in the chat window here. With that, I'm done. Like, I'm pretty much covered whatever I wanted to cover it for today's session. Provided I'm going to spare a few more minutes if anyone has any questions or queries to discuss. Otherwise, we're good to stop it for today.
Yeah, Malik. Hi.
Yep.
Yeah, for tomorrow and day after tomorrow, are you going to take any session for new DBS, new
No.
Oracle?
No. Once it starts on Monday, later we're going to, who are registered only for them. Again, Nisal will be communicated in our group. As I said, we have that dedicated WhatsApp group. We're going to communicate on that particular group for all the registered students, what we're going to take, what we're going to take, what we're going to cover.
Hi, Malik.
Yep.
I see that the course about RAC already started the 1st of April.
Right.
And I see that the registration is still open.
Yes, you can ping me and my WhatsApp number. Probably will take it offline.
Okay, thanks.
Yeah. All right, guys. So any more questions before we stop or wind up for today?
Is this cover the course content of Oracle certification?
Yes. Whatever needed for your admin 1 and admin 2 will be covered pretty much on this particular course.
Okay, 1Z0, 0, 82 and 83 will be covered. Course content will be covered.
Right.
Okay,
Again, you can go to that course content as well as the certificate content and you can match it.
Okay, just a query. Thank you.
Yep.
Because the main agenda is to pass that OCP certification 19C, 82 and 83 one. So we'll be needing your help, Malikarjun.
Right, definitely.
Yeah, Malik, I'm not able to see the basic Linux videos you already shared. You said short videos are uploaded, right?
Again, we'll take it in our group. So I'm going to post it over there.
Mm-hmm.
All right. So any more questions, guys, on the course curriculum or the content?
So Malik, one question on the fly. It was the interview question to me. Okay. I'm not sure whether it was the right question or not. Let me ask to you that question so that I will get some understanding. Let's say one query has been fired from the user and it's running and running and running.
Right. Again, take it offline. That is a PT is not that easy. If I try to explain, it's not going to take. No, it's going to take 1 hour, 2 hours.
Take that offline.
Yeah. Those are the common questions. My queries used to run for 1 minute. Now it's taking 10 minutes. Yesterday,
no, that's the common question. That's the common question. But what he was asking is how much data it has fetched. Can you tell me that? Yes. It's still running. How I can do that? Right?
Yes, we can do that. Just to give you context on that, since let's quickly open here, I can quickly show you. There's so many views you can pretty much get all those. Let's go here. This is what query you are going to use it. Let's go here. Let's share my screen. So we have something called get rows fetched by the processing. If the user query ran and then I wanted to understand that particular SID, how much data it is fetching it out, you're going to use this $V statistics and you're going to combine this stats and team stats and how much percentage of rows are getting. So you have to give that SID, which SID you're going to tracing it out and how many rows are fetched and how many data is fetched by running this $V statistics. You're going to see, understand, like right now it is 222 and then it will keep on getting here. It's a 504340 507722. So number of rows getting scanned. So with the session statistics, you're going to get that on. Everything is doable, but you need to tune your queries accordingly.
Great. Got it. Thank you.
All right. Right, one more last questions I got from Srinivasan here. What is the default number of data files, read log files, control files? Again, one control file more than enough to run your database, and minimum 2 read logs is more than enough to run your database. And number of data files, minimum your system sysocs 1 user and one temp and undo. 5 data files more than enough to run your database. And as and when your database grows, so it's gonna be keep on increasing your data files. Right. So Peter is asking, can we still make a payment over the weekend? Yes, of course you can do before Monday starts. You can anytime join the course, and provided if there's a limited seats, so I can add you guys. Otherwise, once the seats are full, I cannot take further admission. All right.
You will help to set up the environment and everything at our local machine, right?
Right. That's what I said yesterday. Very first 1 week will be fully set up. We're going to set up with ASM, without ASM. We're going to set up lab 1, lab 2, lab 3, multiple labs with all the shared disk with ASM and without ASM. Everything start from the scratch. All right. So with that, last point I wanted to say, happy learning, and we'll see all of you guys on our actual classes starting from Monday. Thank you, everyone. Thank you all. Bye.